Applications that we're going to go through throughout the year. Linear and angular velocity is the first one we're going to hit here with trig. Linear velocity is velocity that you've talked about forever in your math and science classes. It's just a straight line speed. So we talk a lot about meters per second, miles per hour, very standard for a linear speed, just meaning a straight line speed. Angular velocity is something kind of new. Basically, it's a rotational velocity. So like if you imagine yourself in a car, there's my terrible car, as you are going down the highway, you have a linear speed. It's what your speedometer says. However, your tires are rotating as you're going down the road. And the tires, if you're going 50 miles an hour down the road, tires are rotating at a much different speed than that. The tires rotating allows you to get to that speed in miles per hour, but basically we're going to say as this tire or wheel or whatever rotates, it has its own speed, and we measure that basically in an angle over time. So radians per minute, or even potentially radians per second or hour or whatever. So the main thing we're going to do is we're going to have to do a lot of conversions upcoming, and a lot of it deals with the amount of time it takes to go one time around, which is going to be called one revolution. Well, if you're going with a revolution, meaning you're going around the circle, we've always called one time around the circle like a circumference. What's the formula for circumference? Is 2 pi r, 2 pi times the radius. Really big part of the formula. And then one time around the circle, if we're talking about degrees, would be 360, but we deal with radians, which is why it's 2 pi radians. Make sure this is starred, boxed, whatever it may be. This right here is the big formula, the big conversions that you may possibly have to use, converting from revolutions to radians to some sort of radius linear version, this radius here being possibly feet, inches, whatever it may be. Make sure you have this guy marked down as you look into your examples coming up.